PET is a fully recyclable polymer that can be easily identified by the number 1 code in the triangle chasing arrows icon that is usually molded into the bottom or the side of the bottle. This number 1 is exclusive to PET. Sorry. Since the polymer is inert, it won't be attacked by microorganisms, which means that it will not biologically degrade. And if not recycled properly, it can accumulate in the environment for 450 years, approximately. Nonetheless, in some research performed in 2016 in Japan, it was isolated some PET degrading bacteria, and it was seen that they could colonize and break down a thin film of soft PET in the span of 6 weeks. They did this by use of two enzymes, which are PETase and METase. Firstly, PETase will hydrolyze the ester bonds, giving rise to these two molecules, and subsequently, METase will break down this molecule MET into terephthalic acid and ethylene glycol. During this research, these two enzymes were also isolated, and this could be advantageous due to their high specificity. Commercially, the recycling of PET can be done in two approaches, a mechanical approach and a chemical approach. In the former case, it's done by a thorough washing and remelting of the polymer to form new products. And in the second case, it consists of chemically breaking down PET to its original components and restarting the whole process. This is usually done for plastic that is more contaminated. It can be done in multiple ways. Here are 3 examples of reactions that can be performed: hydrolysis, methanolysis, and glycolysis. Hydrolysis uses water and it allows the obtention of the original monomers directly. In the case of glycolysis and methanolysis, which are performed with ethylene glycol and methanol, instead of obtaining the original terephthalic acid, as in glycolysis, a derivative is obtained that needs further synthesis to obtain the original monomer. As we have just seen, okay. PET is a fully recyclable polymer and can easily be identified by the number 1 code in the triangle chasing arrows icon that is usually molded into the bottom or the side of the bottle. Since this polymer is inert, it won't be attacked by microorganisms, which means that it will not biologically degrade, and therefore it could accumulate in the environment for approximately 450 years. Nonetheless, in some research performed in Japan in 2016, PET degrading bacteria were able to be isolated. These bacteria could colonize and break down a thin film of soft PET in the span of 6 weeks. They do this by using two enzymes, which are PETase and METase, which is over here. Firstly, PETase will break down by hydrolyzing the ester bonds in the original polymer, giving rise to these two molecules, VET and MET. And subsequently, METase will break down this second molecule into the original monomers, terephthalic acid and ethylene glycol. Commercially, this process can be done in two approaches: a mechanical approach, which consists of a thorough washing and remelting of the polymer, and chemical approach, which degrades the polymer into its original monomers. This second process is usually done when the polymer is more contaminated. It can be done in several ways, such as hydrolysis, methanolysis, and glycolysis. In the first case, we obtain directly the original monomers, but in glycolysis and methanolysis, instead of the terephthalic acid, we obtain two derivatives that need further synthesis.